We're going to be looking at a Leetcode problem, longest substring without repeating characters. So given a substring, find the length of the longest substring that does not repeat any characters. So if you look at here, we have ABC, ABC, BB. And of course, ABC is the longest without any repeating character. Of course, you can have CAB, all right? You can have, but yeah, ABC, I have CAB. And yeah, this is about the, yeah, and another ABC, all right? So for BBB, of course, it's just one. B is the only one without. So for here, for the PWWK, so we have WKE and we have KEW, and they're both of length 3. So how do you actually solve this problem? So when you hear a problem that talks about with optimizing for not repeating something, this is a good case for using hash map or a set. So if you have that, you can solve it, which means if you're going from left to right, if you found it, just don't count it. All right. So one thing you also need to remember is when you're okay, so let me explain the algorithm. There are two ways to solve it. You can solve it using a hash map, and you can solve it using set. And I'm going to go through over the two just to and give you the pros and the cons. So how do you actually let's explain the algorithm, the thinking behind it. So if you're going from left to right, if A is not if A, because we're going to maintain let's call it set for now. We're going to maintain a set data structure. If A is not in set, add it into it. Okay. But wait, no. It's not just if it's not in set, just add it into it. Okay. Then B, and until you get to a character that's already in. And when that condition is met, you have a character. You keep shifting the left pointer until you remove the character that is in, and you keep shifting the pointer. All right. So let me demonstrate what I'm trying to say. So first of all, we need the character longest and 0 and return it. That's how I like to solve it, so that you remember what you're doing. So remember, we're going from left to right, and we're having. So if we're going from left to right, we also have another pointer keeping track of where the character began. So what I'm trying to say is, if you have a pointer at A, we can have another pointer going through here. So it means if A is not in this, if the next character B is not within what we have before, then we can keep going until we encounter one that it is. So when we encounter A, we can then cancel A out. We can not cancel. Well, we'll cancel it, but we can move the pointer here, then remove A, which is this one, from the set we already have, and then add this one in. Okay, so and perform a calculation to obtain the longest. So what I'm trying to say is, so let me create longest and my scene set class. Okay, and then left pointer, which will be at index 0, and right pointer will be at index 0. But because we're going from left to right, we can just put it here in our for loop for r in range len s. Okay. Next is to check if. But before we check, just to make this more easy to follow, before we check, let's add it in. So we're just gonna say sr scene.add. Okay, and then you're gonna do longest equals to maximum. Well, let's do the calculation. So it should be r minus l plus 1. Okay, so for example, you're here, you're the first, you're here. Okay, this is where you're at now. It is A ABC. So it will be, remember, is 0, 1, and 2. So if you do 2 minus 0, that will be 2. And that's not essentially what I'm trying to explain is this is a 0-based count and we need a 1-based count here. So that's why this plus 1 is necessary. So of course, this maximum is necessary because we're trying to find the longest. So that's why I'm going to introduce max here, just so that if you're going from left to right, you might see something that is bigger, okay? And if you don't want to update this when you see something that is lesser. So for example, you don't want to update when you see BC. Now, the condition I talked about is if it's already in scene, if the character is already in scene, all right, what you need to do is shift the left pointer. Well, first of all, remove it from the scene, remove the character from scene, and shift the pointer, scene.remove, what I wanted to type, pardon me. Then you need to shift the left pointer by 1, left plus 1. Now, I'm going to show you why this if is not good enough. All right, and let me just run it. Yeah, I forgot I left my tab open for, yeah, but it's good to see. So as you can see here, you have repeating characters. So because we used 1, you just check this condition what's it called now? We checked the condition for if seen only once. So if you just move the pointer only once. So let me demonstrate what I'm trying to talk about. So you have PK. Let me find a way to increase this. Oh, there's no way, but I hope you can see it. Let me try and make it bold. All right, so here we are. PKWW. So initially the set will be P, right? This is the set. I know this is tiny, but please bear with me. P, then the next one will be W, okay? Then we encountered W now, another W. So because we've seen this before, we shift the pointer. So let me create another one, another left, right. So initially we have left stays at 0, this stays at 0, okay? Then 0, then this one moves to 1. Then because nothing is in it's not in the scene, so it adds to, it just goes on. So 0, 1, and then this is index 2, index 0, and index 2. All right, so what happens is this W has been seen before. So we shift it because our current implementation only shifts it by 1, right? So if you do that, the left now becomes 1, and this becomes 3, and so this summation, the difference is what's obtained here. So it's not seen that there's another W again. So okay, so this will be 3. Okay, so now we're here and this is here. So we keep moving. That's how it is. So because to combat this repeating character phenomenon, you need a while loop here. You need a while loop. So let me just run it. So that to skip, whenever you encounter this, that's not right. No, SL. SL, not this one. Yes, this is what we're removing. So yeah, sorry about that. It is, so we're removing the former one. So this index, yeah, 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 that's what we're removing. I hope that makes sense. It's a bit tricky to understand, but that's how it is. So we're removing the last one here.